Thanks so much for your patience. We are at the 8:56 mark here in Texas, so we have about 4 minutes before I'm going to let Richard take over. But before I go ahead and pass it over to him, as you can see, he's here. Welcome, Richard. I'm going to just do a little bit of a background on Richard. You know, we've here at Calculate have been friends with him for a little while now, and our CEO and founder also has spoken with Richard and has some really good background there. So before I pass it over, I'll just do a quick intro if that's good with you, Richard.
Absolutely.
Cool. So, and correct me if I'm wrong on any of this, but Richard is the CTO and founder of Robokind, which is an education company actually using facially expressive robots, if I said that correctly, in schools to teach students social and emotional learning and computer science. He has been, creating facially expressive humanoids of all kinds for more than, I think a dozen years or so, and has current generations of robots, as you can see behind him, that are the only mass-produced facially expressive robots in the world. Also has led the design of the hardware, the software, which I think, for the EMS space and the attendants we have here are very familiar with how that plays in our world. Taking these robots from initial design to manufacturing to deployment in hundreds of different school districts across the US and other countries. So definitely a really interesting relationship there and kind of what you've created so far. And specifically today, going to be focusing on, taking through the experience of actually creating these, deploying them to specifically the schools that are helping teach this social and emotional learning and computer science, and how that's kind of changed over time, I guess, if you will, as well, and into kind of what today's world looks like. So I know we're a couple minutes early, but I think you have some really great content to share. So if you want to go ahead and feel free to do a better introduction than I just did, if you have anything else to add. But if not, I'll go ahead and just let you kick it off. And we're really excited to have you here.
Awesome. Thank you, Caitlin.
Yeah, absolutely.
I'm excited to be here. So I'm, as Caitlin said, I'm Richard Margolin. I'm the CTO and co-founder of Robokind. We build facially expressive robots like these. We've got actually 4 different characters now, 2 males and 2 females. These are the males. These are what I pulled this morning, but we use these robots in public schools to teach social and emotional skills, primarily to kids with autism and other special needs, and also teach computer science. What I'm going to talk about today is really both what we do, but then what it took to design a product like this. As I was talking to Caitlin earlier, I kind of mentioned, and I frankly haven't thought about in a long time, these are actually my first manufactured production product. Prior to creating these, I'd built, dozens and dozens of robots, human size, robots that looked like animals, all kinds of stuff, but nothing, they were all one-offs. They were for museums, they were for universities, and this is really the first and a very ambitious product to start with. So I'm going to start my screen share. Hold on. And hopefully everyone can see. And yeah, all right, cool. Basically, as I said, these are our robots. Here's a little bit of my background, just for some perspective. I have kind of a strange background as it goes. I started actually as a geneticist when I was 13 years old, working on the Human Genome Project at a lab here in Dallas, UT Southwestern. Worked both on the Human Genome Project as well as canine morphology, which kind of got me early into CAD, neural networks, things like that, because with the dogs, while the Human Genome Project sounds cooler, the thing with the dogs, we were trying to figure out what made dogs shape the way they were. And so I had access and used pretty advanced CAD for the time, supercomputer clusters, and 3D scanners to create a lot of things. I then moved over to Nanomaterials Research Lab after the Human Genome Project ended, and worked on carbon nanotube-based materials and processes for a time. I realized pretty quickly that I really liked working on things I could see. So nanomaterials, chemistry, biology, frankly, weren't really my thing. And I went to undergrad and started studying neuroscience, where I joined my first robotics team. And that's really what got me started down the robotics path. I'd always liked making things and building things, but I just didn't really have that exposure to hardware, electronics, things like that in high school. We didn't have the types of robotics programs a lot of high schools have now. And then after I got my neuroscience degree, I went and I worked a number of places doing different kinds of robots. Ended up at Hanson Robotics, where I started as an intern while I was doing my mechanical engineering robotics degree, and became their engineering director after just a few years, and helped to create and design several dozen realistic human scale robots that got a lot of notoriety. And that's where I saw that we could potentially use robots like that to help people with autism, because a lot of our customers were university research groups, and I ended up supporting a lot of autism research across the globe and saw the potential. Other thing in terms of things I like to do, I'm not explicitly a robot guy. I just like to make things. And lately, this last year, the fact that I make origami as a meditation, basically, or a neurotic obsession, depending how you look at it, has been covered a lot recently and just keeps going. So I've kind of strangely become an origami guy as well. As a quick overview, our Robots for Autism program, we put them in primarily public schools. We also work with private therapy centers, but public schools is where most of the kids are in the US, so that's where we want to be, because we can help the most people and have the biggest impact. Basically, our robots actually act as the teacher and the co-therapist. So this isn't just a nice toy. I mean, we're actually delivering curriculum and therapy through these robots, using these robots. The teachers, paraprofessionals, whomever happens to be available, are facilitating, but the actual learning materials come directly from the robot. So, you know, why is, I think, the big question, right? So for people with autism, a lot of them, and this is a generalization, have trouble engaging with other people, with social skills, social interaction, emotional recognition, things like that. And because of that difficulty engaging with other people, traditional one-to-one, human-to-human therapies can be really tough for a subset of kids. You know, the robots aren't. So we're able to help a lot of kids for whom therapy has historically not actually worked that well. And, you know, robots can do things we can't. You know, same things, frankly, your robots do on industrial lines and factories and, you know, a number of environments. We can provide perfect consistency, repetition, and, you know, really coordinate a lot of things simultaneously in ways that people can't. So with that, we have 16 topics we cover right now in our autism and SEL curriculum, and 142 lessons. And, you know, back to the things people can't do. We collect data passively as kids interact with the program, just in ways people can't. And historically, classroom data for these types of things has been very subjective, handwritten notes, and that's about as far as it's ever gotten. And we're bringing real quantitative, in addition to the qualitative data, into these classrooms, making it actionable. So the robots, you know, actually like I said, they're consistent, they're predictable, and that yields a lot higher engagement than we've had historically in human-to-human therapies. The robots also never get tired, they never get frustrated, they've never had a bad day. You turn them on, they're ready to go, and people aren't that. So this little chart here on the side also shows the other kind of dirty secret in therapy with autism, which is because of that difficulty engaging with other people. Historically, you're only getting about 2 to 3% engagement during any given learning session with a student, whereas with our robots, it's almost 40 times that. It's 87.5%. And so we see amazing results very quickly with a lot of the kids we work with. And there's a lot of evidence to kind of behind these statements and research, but it's really because we're able to engage these kids, and that's where learning starts. It doesn't matter if it's special needs or not. You need to engage people to get them to learn. All right, I'm going to warn you. The next slide is I'm showing you what the historicals have been, and it is startling. So this is something a teacher sent me recently. This is what they were using before they got our robots in their classroom. This is trying to teach mouth position, facial expressions, things like this. This is what they were using. It is scary. I'm about to show a video also to show you, when I talk about engagement, what the real difference is. This is a real student during a study. Kid's name was Cole. He was 14 years old. He'd been in therapy since he was 2, and was still nonverbal and non-communicative for the most part before he met our robot Milo. So this is him with his therapist. He's compliant. He knows what he needs to do because he's been doing it for a long time, but he has trouble engaging, making eye contact, things like that.
Let's play a game.
And here's his second time working with Milo.
To play a game called Follow the Leader. First, I'll be the leader.
He's fully engaged. He's paying attention.
Then you do the same
He's
thing.
responsive.
Ready? I can move my arm.
At 14, he went home and said hi to his parents for the first time that day. So what does the interaction look like? What's all the kind of magic we put together, if you will? But basically, the robot leads the interaction like you saw in that video. What you didn't see is we have a little screen on our chest. It's a little touch screen, but we use it to basically show flashcards. So we're able to reinforce important vocabulary. The robot speaks. We're able to slow down the speech so kids with auditory processing issues can absorb more of what's being said. And then the facilitator has a tablet and the student has a tablet. So we explain things to a student using a therapy process called social narrative, and then we show videos of kids actually doing it, and then we assess. And so I'll actually, towards the end of this, I'll grab one of the robots behind me, and I'll show you what that looks like for real, and what our robots can do. So getting into what it takes to create something like this. So humanoid, why is it important? I think there's a lot of baggage that comes with building a robot with a face, but we are explicitly and expressly creating robots that are intended to perform social interactions, to teach social interactions and emotional interaction and emotional recognition. And doing that without a face is difficult, if not impossible. I've seen other older robots who were used in autism research who, when they get to, what does happy look like, because they don't have a face, they dance around, and, it's just not accurate to humanity. So facial expressions are really important. The chest screen and the icons we use to display, these reinforcement mechanisms. This is super old, best practice education, just modernized, right? So now, instead of having these flashcards as a separate thing, they show up in perfect synchrony with the speech, and that allows kids with varying types of processing skills and deficits to absorb more of what's being said. Same thing with slowing down the speech. It gives them more time to process the information. So as I mentioned, we also have videos that show kids doing it. So we explain it and then we show it, and we show it a lot. And so as part of this, we had to film, I think it was about 1,700 little 3 to 10 second vignettes. And then the data. So we can collect data in ways no one's been able to historically. And the net result of that is we're able to provide them much more actionable data, much more awareness of how these kids are actually doing, and do it in a way that they can actually really, use it and learn quickly. And that's something we're constantly working on. But the thing that's awesome, frankly, is because historically there hasn't been great data, and because we basically get to run, nationally distributed studies, we actually at this point collect more data in your average school week than the largest autism therapy studies in history. And we work hard to make that actionable. We work with universities to find, interesting, useful new things out of that data. And then in a lot of cases, we try and make, especially if it has to do with better practices than what's been happening, we make that public. We don't hoard it. We share as much as possible. So let's get into the actual hardware and the design process. As I said, this was my first production product. So this is what we've got. It looks like a cute toy with a face that moves. On the inside, there's a full tablet processor, all the types of sensors you'd expect that come with a tablet processor, like an IMU and things like that. But then we have 2 different types of IR distance sensors, a time of flight. We were actually really fortunate, just I think because of what we do and how, a cool looking product, frankly. ST gave us these time of flight sensors prior to their first release. And so we were actually able to, I think we were the first product on the market that actually had that type of a sensor in it. And then 2D distance sensor, and then lots of motors with feedback, real servo motors, and a lot of safety built in as well, and a microphone array, which I'll talk a little bit about more in a later slide. But this is the very fast overview of what we do, and all of this enables us to collect different types of data depending on what we're doing and what we're teaching. So, how do you go from basically a sketch like this and a vague system diagram into, real product that has 21 servo motors, 19 sensors, 36 individual circuit boards, 1,200 plus mechanical parts. You do it with a lot of engineers, a lot of software developers, and an optical physicist. And that's kind of, what we did, as well as a lot of artists. Some of these parts, and this may be more about how I like to work than, there are other ways to do it full digital from the start, but we sculpted a lot of the parts physically and then 3D scan them, because it gives you a lot better sense of proportion, in my opinion, and it's a lot faster even than 3D printing, and you get an object you can hold very quickly, and you can play with texture and finish and things like that much more quickly. So every mechanism, every part of this robot has embedded servos, embedded potentiometers as feedback, embedded sensors, and then wire management, and all the things that a crowd like this really understands, how to deal with. And, especially when you're building anything that moves, you have to remember, simple things like wires have volume, take up space, and can't just magically bend, 180 degrees around a corner, which, was something I knew, but when you're in CAD, it's easy to forget. So, we built it, or we designed it, we simulated it, we 3D printed it and built it again. And, so you learn a lot once you have physical objects in hand. And sometimes things don't always work as you'd expect them to. For instance, our walking mechanism, because our robots do walk. It's a rudimentary walk. I think we went through 5, 6, 7 iterations of real reworks of the design, because even with good simulation and things like that, the robot kept falling over, and that does not make a good product for a classroom. So, microphone array is another one. This predated like a lot of these personal assistants, Amazon Echo and Google Assistant and things like that. And so we weren't able to buy an off the shelf. And so we had to learn the physics of sound to do the types of things that now you could just get to buy, and design a microphone array that was able to cancel out all that motor noise, and do directional audio localization, those types of things. And that helps us, to this day, when we do a next design, which we're starting soon, we'll just be able to buy it and, plug in APIs. We were, I think as I've started looking at our next designs, it's going to be a lot easier and a lot faster, thanks to a lot of the types of things that people attending this event have created, because there's a lot more out there that's easier to use and easier to prototype with a lot faster than when we started this process. So we also had to develop brand new materials. This horrible yellow skin was on the way to getting the material for the face, because when I did those older robots that were bigger and substantially more expensive, we were able to use materials that were very expensive, like silicone rubbers, develop processes that took a lot of time to process the material, and to, as part of getting the cost down from the types of robots I used to build, which in some cases were, several $1 million, down to something that the full package, not just the hardware, can actually go into a public school classroom. Involve, we couldn't have a face skin that took 38 hours to create. We needed something that was injectable, but we also needed something that could make good facial expressions. And we actually had to develop a new material, develop a secondary material for overmolding, because nothing would stick to the first material, and then develop a whole new process. And then, the nerve-wracking thing when you're making product is at some point you have to commit and put everything into tooling. And for something like this with 1,200 parts, that's a lot of tooling. And so we built the tooling and we got going, and I'd like to say we never looked back, but it was, there was a lot of problem solving, a lot of testing, a lot of lemming robots that were, built just for destruction. And then, all the regulatory testing. I'm sure plenty of y'all have been in rooms like this, whether it's domestically or abroad, and, trying to keep up with all of that as a small startup company was an interesting set of challenges. But luckily we had, amazing help and amazing support, and, people who had been through it before that helped guide us. And so I try to provide as much help back as I can now. I've built out a lot of resources for people designing their first product, on how to work with your first factory, how to, what you need to think about, what you need to worry about in terms of the practical, hardware design, manufacturer, but even the regulatory, the trust in picking a factory, all kinds of intellectual property, things like that. And so that's, resources that worked on with some friends who had gone through the same thing with that, who have even bigger, much bigger companies than I do. And we try and share that with as many people as possible and, help them understand what the process is. So besides the STEM, or besides the autism, we also teach computer science. And so we have a full intro computer science curriculum for young kids, like second grade and up, basically. And we created a simulation of the robot in a 3D environment that can run in browser. We did it initially because we wanted schools, in low socioeconomic areas to be able to get a robot, but their kids be able to work on and learn how, even if they didn't have direct access to the robot, and not need one robot per student. And as the pandemic has hit, having that avatar has been a really significant and important thing for us, because it's allowed us to help schools transition to remote learning very quickly. We're actually in the process of also releasing an avatar version of our autism app as a supplement, for the same reasons. Because we work with public schools, we need to meet our customers regardless of what's happening. And so this has been a new challenge, taking everything we've done and that really relied heavily on the robot, and rethinking it as a simulated robot, and making it as similar as possible. And so that's something, basically what me and my teams have spent all summer doing and into the fall. And we're actually, we started releasing a private beta to customers yesterday, and we plan on releasing full product next week to several hundred schools across the United States, Canada, and other countries, as well as tens of thousands of kids. So it's fun, and it's exciting, and it's also nerve-wracking, as is any product release. So that's kind of where we're at right now. So let me.
They're used to just sitting at a computer to code. So when they really got to see
what this
they're
is.
able to move things with their abilities and with the coding, it was amazing.
I found that the most engaging computer science curriculum always is centered around some sort of immediate kind of picture of what you're doing. And so a lot of times you're going to see a stage area where the characters or whatever, they accomplish what commands you're giving them to do. With Robots for STEM, it brings that character out of the computer screen, and you're directly looking at it.
A lot of times kids can connect with their learning, and so it gives them a purpose, and it lets them see real life actions of what it is that they're using the computers.
As they figure out more and more about the robot and what it can do, it's definitely stirs some excitement more and more kids. And having them see what they can produce is super, super beneficial. And the kids have just reacted great to it.
They're used to just sitting. They're used to.
There we go. So we'll do a demo here in a second, but seeing what it really looks like in the classroom, seeing it ending up in the real world is always a pretty exciting and meaningful experience when you put years of your life into a product. And that's something that I think I've had the benefit of, everyone at Robokind has had the benefit of, knowing that the work we do ends up being really impactful for a number of kids. With our autism program, I think we're just north of 20,000 kids, and with our computer science program, I think it's in the 40,000 student range, using our products every day. And we've had to build build to that and build robots that are durable enough to survive in the classroom. And that unto itself was a challenge. You know, I think you've heard me use the word impact a lot. That's I think the lens in which I and my team really think about what we do and the product we create is, you know, what is the end impact? And I think that it makes it a lot easier to get up every day and really, you know, work to improve this, because we know that everything we do is going to have a really positive impact. So here, let me stop the screen share so the screen is bigger, and I will do a quick kind of actual showing off jet here. All right, so let's see. Okay, so we're going to start off and really show off the facial expressions, because this is something that is unique to us. And, you know, I think until you see it, really kind of getting a sense of what a robot like this is, what it does, and, you know, how much goes into making something like this work. For people who develop product, I think you have a sense very quickly of how much goes into something like this. And, you know, I get the credit for all of it usually, but, you know, there's been hundreds of people, hundreds of hands involved in creating something like this. So, all right, so I'm gonna re-share my screen real quick, and this is what I'm about to show is a slightly older version of our app, but it's one that's easier to screen share right now. So let me get that started again, but I'm gonna run through an actual lesson or a portion of a lesson really quickly to kind of really help show and share a sense of what the autism lessons look like. You saw a little bit of a student working with it, but I think it's you get it a little bit more when we run an actual lesson. And since we're since we're at the nearing the end of this, before we get into the Q&A, I'm going to teach everyone how to say goodbye. So as I said before, you know, there's a facilitator tablet, there's a student tablet. So this is simulating both views side by side. And Milo will speak. You'll hear the speech is slow and kind of paced very intentionally. I'll see if I can get the glare off, but you'll see the icons on the chest, and you'll hear the social narrative portion, which is basically process-oriented learning, which for a lot of engineers and design people is really, I think it makes a lot of sense. You know, basically the process, the narrative you'll hear is when we leave someone, we look, we smile, we say bye. Look, smile, say bye. You'll hear it over and over again, and then you'll see kids doing it, and then you'll see kids doing it wrong, and then we'll quiz. And that's really kind of the structure of not all, but a lot of our lessons, especially around social communication. So this older app's a little slower, so it'll take a second.
Hello. We have talked a lot about greetings. You just gave me a greeting to say hello. You looked at my face, smiled, and said a greeting or This is called leave taking. When we are leaving a friend, we look at the friend's face, smile, and say bye. I can say bye to other kids. I can say bye to grown-ups. Bye can be a formal or a casual leave-taking word. Let's see some of my friends saying bye. Look at the tablet.
Bye. Bye.
See how my friends looked at each other's face, smiled, and said bye. These were good ways to leave someone. Let's watch more, friends. See if they can do it right. Do they look at each other's face? Do they smile? Do they say bye? Look at the tablet.
Bye. Bye.
My friend did not do something. She needs to try to look at her friend's face, smile, and say bye. My friend did not do something. What does my friend need to do?
So here's where we get to the assessment part. Basically, we're reusing these answer buttons, these answer icons as the answer buttons. We learned very early for a subset of the kids we work with, due to lack of intelligence or anything like that, but often due to just some of the other social and emotional problems or deficits they're dealing with, they may still be illiterate. And so when we went from just words to the full icon, we found that we were able to actually work with another kind of 40% of kids that were, needed more support and were, in more kind of, I guess, severe classrooms, things like that. With like a lot of people and a lot of companies, we learned a lot from our customers doing things we told them not to. Very early on, we told them, we were good for, kids who were higher functioning, kids who were, really like 8 and up, things like that. And some of our earliest customers immediately put it in kindergarten special needs classrooms with kids who had regular violent meltdowns and things like that. And that showed us, one, we could help those kids a lot. We have amazing calm down tools and calm down modules that every student goes through, no matter what. And frankly, I think they're good for everyone, that really help with self-regulation, help reduce meltdowns, things like that. When we talk about impact, again, talking about impact in the classroom, just these calm down tools before you get to any of the other skills that we teach. We on average are able to reduce meltdowns in classrooms by about 80%. And so for those unfamiliar, meltdown, from the outside looks a lot like a very severe tantrum. It's much more than that. For these kids, they're getting overwhelmed with a lot of sensory overload in a lot of cases. For many of them, they don't know how to communicate what's wrong or what the source of the stress is, and they kind of spiral until they physiologically melt down. The other side of that is a shutdown, and kids who shut down tend to go silent and still in pretty severe ways. But reducing meltdowns in a classroom by 80% when you've got 6 to 10 kids who may each individually have 1 or 2 meltdowns a day, and these can be pretty severe, and they can last 20, 40 minutes, an hour sometimes. And so this changes the dynamics of a classroom. We're able to give teachers the ability to teach. We're able to, in some cases, increase actual focused teaching time in these classrooms by hours a day. And it's really pretty crazy how well this works. And the reality is, and I should emphasize this, and I do emphasize this, there's no magic here. This isn't a cure. It's not anything other than we've taken as many of the best evidence-based practices you can find. We've crammed them into a program, and we've figured out how to get a robot to deliver most of it. And that's really what we're doing. And the result, I think, has been beyond anything I would have ever hoped for. So that's really, just a point I'd like to make. So let's keep learning how to say bye. The other thing I'll emphasize is, in that video, which I know I've talked a lot, so it was forever ago, the girl on the left didn't look. If I pick the wrong answer, we go right back into a positive teaching mode. We re-explain it, we re-show it, and then we quiz again. And then if we get it wrong a third time, we actually try and explain it a different way. And so all of this is, things we can measure. Time to response is part of our measure too, because we can see as kids start to get it, the response time tends to be faster, in addition to, actual raw scores being correct.
You're right. My friend needs to look at her friend's face. She looked away. Thanks for helping my friend with leave taking. Let's watch them do it right.
Bye. Bye.
Let's watch another friend. See if they look, smile, and say bye.
Bye. Bye.
My friend did not do something. She needs to try to look at her friend's face, smile, and say bye. My friend did not do something. What does my friend need to do?
All right, I think that girl didn't smile. Well, we have both views up, so we get the answers from the teacher. The other thing I'll add is, so ultimately our goal is not how well do they score on this, right? It is teaching these skills and then generalization, which means actually taking this, learning it, and then using it with other people. And so everything I've showed here today, this is the flashy part of the course, the curriculum, everything. The other side of what we have is our kind of practice activities or extension activities that use what are called in therapy or psychology, structured and unstructured, or naturalistic and unstructured practice, where basically we do all of this and then we transition to working with people, because at the end of the day, that's all that matters in terms of outcomes and long-term impact, is that going home and saying hi to your parents for the first time, and being able to participate in class, and not being able to control your meltdowns enough that you're able to be in a mainstream classroom and get a better education. And as amazing as the stories about kids who go through one or two lessons and are able to do these immediately, the other side of that I frankly think is more amazing and really speaks more to the importance of technology like this, is we have kids who have been doing this lesson or something like it for 3 years and literally done just these intro to greetings and leave taking lessons over 1,000 times, and then finally made breakthroughs in being able to use these skills. And the reason I think that's more amazing is you think about, consistency and repetition, and would a person, doesn't matter, the most caring and wonderful person, teacher in the world, could they do the same lesson that consistently thousands of times? In a lot of cases, there's turnover in schools. So as well, especially in special ed, basically it's like 50% turnover every 15 months, I think. So, these kids have that consistency, even if they don't have consistency with their teachers or their staff. So the rest of the lesson looks very similar. So I'm going to kind of stop it here. And I think we can jump into Q&A at this point because I want to leave time for that. Yeah, so let me move this.
Absolutely. Well, Richard, I'll just add and say I think that was probably one of the most incredible and like impacting things that we've seen, and really excited to have that. And just the comments in the stages here really was a huge impact and really cool to see. So thank you for showing all of that to us. I'll say to everybody else, please feel free to put in your questions, encouraged to put in some questions in the stage chat or the event chat. I just have some general questions, if you don't mind me asking a few of them. Okay, cool. One, I think, being in the industry that we're in the EMS space, and I'm sure some of the attendees can agree, you always make mistakes. And especially when you're designing something and prototyping it and going through the manufacturing process, what would you say is the biggest mistake that you've made along the way that's taught you also the biggest lesson?
I think the biggest mistake we made is for me and my VP of engineering, who he and I did our engineering program together and actually started building robots together, like for professors and things like that. We relied early on way too much on the simulation and weren't building prototypes fast enough. So one of our biggest mistakes in terms of actual production and not testing the worst case or extreme enough. So the battery we released with our initial production run couldn't actually put out enough power when like the robot was dancing. When every single motor was moving simultaneously, it would brown out. And on paper, based on our estimates and our calculations and stuff, it should have been enough. But the reality of it was we were wrong, and we had to actually do a battery recall and remanufacture them. And that was very early. We didn't catch it pre-production because all the testing we were doing were basically unit test type tests. Make sure this arm can move and make sure and make sure the smile looks good. But we never did the make everything move at full power all at once, in the worst case possible, only on battery. And I lucked out a lot because we had an early, like an engineering production robot I was in China at the time. We sent it back to the US, and one of our other execs went and did a live on air on MSNBC product, and somehow it didn't die live on the air.
You always love those live demos.
Exactly. And I've had some worst case live demos, even earlier in my career with what was really a very early prototype of one of these. I was live on air. I was at a AAAI conference and in Chicago, and it was still like all 3D printed parts and stuff like that. And I was live on NBC with a national thing, and the 3D print broke at the neck, and the head just toppled off the robot, but was still connected by wires and was just hanging there, to everyone's horror, just still moving, still talking, but not connected to the body anymore.
Right. Okay.
Yeah.
Very cool. Question from one of the attendees here. Well, first, let me ask this, and just to clarify a little bit. There's obviously some commercial off the shelf, like what Robokind is known for things, but also are there custom elements specific to, what each individual needs from that? Or is it a kind of out of the box, it's going to work for everyone because of the behind the scenes software and what it can do?
It's largely it's an out of the box, other than the character, the skin tone, the body color, the male female character, they're all the same.
Right.
The way we've dealt with that is we put too much into these robots. Like there's more sensors than are absolutely necessary for the autism program, but they get used in the STEM program. There's if there's more processing than is necessary, there's kind of more everything. So our solution was to overbuild it, and luckily we're not in a particularly kind of price or cost sensitive environment relative
Right.
to what the entire program is and encompasses, and how we're able to price it.
Okay, awesome. Yeah. And when you're getting, the manufacturing process ready, obviously
Yeah.
something we do is the quoting and the purchasing side of it. How do you guys manage that in a way that allows for the capacity of what you're trying to build, of, making sure you're getting the right components and making sure that you're purchasing them for, margins. We all have to make money.
Yeah.
So how do you guys handle that?
It's a mix. So the factory
Yeah.
we work with is a real tier 1 factory. They do a lot of toy product, a lot of other things. They source about 60% of our electronic components, the easy, obvious stuff to source, but there's a lot that we still have to source ourselves. There's the computers. I think I told you before we started, we manufacture in Israel and have to get them to China. We have to deal with most of the purchasing for that. And then, there's end of life issues too, because this is we're not doing a new version of this product every year. It's more of a 5-year cycle. And we have recently had, going into this most recent production run, some unexpected EOLs that, because we're still a small company, we didn't really know about it until we were getting the production run started and had to do some very fast redesign, recertification, and things like that. So I think the answer is we could do it differently and better. Right now, it's mostly just brute forcing it, and very lucky in our ability to kind of replace things as necessary without it causing too many problems.
Right. Yeah. I think that's something that every company goes through and has to experience at one time or the other, no matter what specific scenario or what process they have. Well, I'll leave you with one final question. I think is a big thing, not just for you guys or the EMS industry, but industries in general. How have you seen things evolve throughout this pandemic?
Yeah, it's been tough and interesting. We work primarily with public schools in the United States. That's 98% of our customer base. So I think what we've seen is typically we work with schools through the school year and some year round. And in March, everything basically went totally silent. We tried our best to give schools a lot of resources. We just straight up filmed some of our lessons, like the one I just showed you, released them free on our website with lesson plans, with all kinds of stuff. But then we've been developing simulated versions of the robots and getting those. We've basically had to transition and beef up our software team to basically simulate everything we've done historically in person. I think in the long run, it'll be good for us and it'll be good for our customers to have those options. It was something, the avatar, especially for autism, is something we'd had kind of, on the roadmap, but ever being pushed to the farther and farther back, and suddenly we went from developing a few new robot features and software that ran on the robot to, in a 4-month period, transitioning everything we did to cloud, everything we did to simulation, and had to revalidate 100% of our content, which is a lot of content. And so it shifted the entire focus of the company overnight, basically.
Right.
Yeah.
I think that's true for a lot of us, and spikes, peaks and valleys, I guess is the best way to put it. So, well, again, I just want to say thank you so much. There's some really impactful things, and I think the impact of what you guys is doing is so cool to see in such a unique area of what the world is going through. If anybody has questions on Robokind or what you do, where can they kind of go and find you?
Just go to robokind.com, and you've got info about both programs. If you want to see, if you know anyone on the autism spectrum who may benefit from some of those free videos, share them. Just robokind.com, and you'll find everything you need.
Perfect. Well, again, thank you, Richard. I seriously appreciate you guys being here and for everything you're doing. And thank you so much for sharing it with us.
Thank you. This was fun.
All right.
All right.
Great. Thanks, Richard.